another time. We have to continue to learn much about analysis. Today, we are looking at how we can conduct t-test analysis in SPSS. And in doing this, it is very important to first look at the assumptions or the conditions for conducting t-test. And the conditions are as follows. The first one is we must make sure that we have two different variables, the dependent variable and the continuous variable, an independent variable. The dependent variable must be continuous, interval or ratio scale, while independent variable should be categorical, which is either ordinal or nominal scale. The second aspect of it is that randomization is very important, and in this, when we say randomization, it means that our sample must be picked without being biased from the population and should be a true representative of the population. So this is very important. The third one is normal distribution, and this means that the population from which the samples are taken or drawn must be normally distributed. To have this is going to have hand shape, and to have this in SPSS we can use histogram to achieve this. The fourth one is homogeneity of variance. The homogeneity of variance assumes that the sample are obtained from population of equal variances. So also in SPSS we can perform this by looking at the table that's going to be generated for us. Under this, we are going to look at leveling test for equality of variances as part of the t-test or ANOVA. And what is very important here is we must obtain, we must know that the significant value of this should be greater than 0.05. If it is less than 0.05, it means that the variances of the two groups are not equal, and in this we have already violated the assumption of homogeneity of variance. But if it is greater than 0.05, then it is a good data and we can continue to have our results analyzed. The last one is outliers. Outliers is large number or small number that can affect our analysis, and this is very important because we must critically look at all the data to see which one is maybe by mistake is more than, or by mistake is less than the normal range of data that's supposed to be key in for analysis to take place. It's very important. So the next one is types of t-tests. What are the type of t-tests we want to look at today? The type of t-tests we want to look at, there are three number. The first one is one sample t-test, which examines whether the mean of a population is statistically different from a known or hypothesized value. In this, there is a value given to us that we want to test our result. If it is exactly or below or greater than that value, that's what's going to be determined by us at the end of the day. The second one is independent sample t-test. We use when we want to compare the mean score of two different groups of people or conditions. And finally, the last one is paired sample t-test that we use when we want to compare the mean score for the same group of people on two different occasions, or when you have matched pairs. Now let's start looking at them one by one. One sample t-test. One sample t-test, it is when the test variable's mean is compared against a test value, as I said earlier, which is a known or hypothesized value of the mean in the population. The test value may come from different standards. Let's look at an example. In research, we normally formulate hypothesis. So let's take this as an example. The mean score of students to evaluate the teacher is 50 points or greater. Is it possible for that Mr. X to be retained after the semester ends? That is the question. Now, this one will now take us to SPSS to analyze and see what is going to happen. And before then, let's look at the data that we have. For one sample t-test, we have this data. Let's copy it to our SPSS. Let's copy it to our SPSS. So here, I press copy, then go to SPSS. We paste this and make sure that you are at data view. Then you paste it. After pasting it, you come to variable view and give it name if you like. Let's say score. So after this one, you go to analyze, you go to compare means, and we select one sample to test. And here we load the whole score to this place. The options here is the same thing. Just click on continue, then OK. So it's going to generate this result for us. The score, we have 60 students. The mean is 58.733. So that is what we need. And here the score, the t-test is 24.29. The degree of freedom is 59, and it is highly significant. This indicate that it is highly significant, that is 0.000. So by going back to where we stop, so let's now, how are we going to write the output? Is very important. Report presentation. So we can continue this in this form, that one sample t-test was conducted to evaluate the teacher to be retained in the teaching profession if the mean score of the student is 50 or greater. The result is statistically significant. That's why we have mean to be 58.7333 and so on, compared to 50 that's already there. So the teacher should be retained for education and for the duration. And what here is that because the significant level is 0.0001, and that means that it is significant, we make sure that the teacher is still retained because the result is 58.73, which is greater than 50, that we want to use as the value to determine the standard to retain or not to retain the teacher. So that is what this is all about. So let's now move to another one. You are welcome back. In this aspect, we are going to look at independent samples t-test. Independent sample t-test is used when we want to compare the mean score on some continuous variables for two different groups of subjects. That is why we call it independent. That is why the first group have the second group. The first group is independent, the second group is independent. Nothing mixed up. That's why they are independent on their own. And to do this in SPSS, let's look at an hypothesis. There is no significant difference between students exposed to the use of algorithms to solve problems and those taught without the intervention, that is, without the treatment. In this, let's go to our SPSS. In our SPSS, before then, we go to our Excel file. In order to look at the independent samples t-test, we need this type of data, and if you want to prepare your own, it's going to be in this format. So here we have, I will tell you the reason for doing so. So we click here, go back to data view, then let's open another one, another fresh data sheet. So here we are going to paste in, then we are going to have two columns. Then come here, let's call this one group, and let's call this one scores. So now here we can write it as group, and likewise here we write scores. But here, because we have one to differentiate between the experimental group and the control group. So we use 1 to denote control group and 2 for experimental group. In this case, we are coming to value here. We click on value, we type 1 and move to label and write control group, then add, type 2, write experimental group here, and click add, then click OK, and it's automatically there. For the scores, we don't need anything because it's continuous, but this one, it is not continuous, it is for nominal. That is why we have to code it. So in this case, we move to analyze, then go to compare means, and on compare means you select independent sample t-test, and here you can see that we have for test variable, that is the scores, you enter it here. While we enter this in the grouping variable and click define, here group 1 we use 1, for group 2 we use 2, then we click on continue. The options here is still continue that you are going to click, then you click OK, then wait for the result to be generated. And here in the result we have two different pivot tables. We have the first one, scores. Control group is 30, experimental group is 30. The mean score of the control group is 41.8667, while the second one is 75.60, and so on and so forth. Standard deviation 6.6, 9.00 here. Now we come here. This is what is very important. This particular section is very important. Here, this leveling test equality of variance, and the condition here is that if the significant value here is greater than 0.05, then our result, our data, our score are good. Our scores that we have already collected are good, so we can proceed. That is, we have not violated the homogeneity of variance. So but if it is less than, so we cannot continue, that is we have violated the homogeneity of variance. Instead we continue, we look at this equal variances are not measured or assumed here. So in this case we have a good result, and here we have the t-test value is minus 16.518, while the degree of freedom is 58 and it is highly significant, that is 0.0001. You can put 1 here after 0, that 3 zeros, or you can put 5 there. It doesn't affect our result. Now let's go back to report. This is the report. The report says that an independent sample t-test was conducted to find the significant difference between students exposed to the use of algorithms to solve problems and those taught without the intervention. There was a significant difference in the scores for control group, which is this, and experimental group, which is this. So this means that there is a difference because you can see from the mean. Mean for the control group is 41, while mean for the experimental is 75 points, and this one is 41 points. This is 6, this is 9. Then the value for t-test is minus 16.517539 minus. So the p-value paired samples t-test. The paired sample t-test is the third type of sample t-test that we have, and in this, the pair sample t-test is also referred to as repeated measures, and it is used when you have only one group of people or machines or companies or methods or anything, and you collect data from them on two different occasions or under two different conditions. In case of this, let's look at pre-test and post-test. You can see that pre-test is the test that taking place before the students are exposed to treatment or intervention, and the post-test is the one that is taken after they might have seen the practical, the effect of that treatment on the students. So then the pre-test and post-test experimental design are good example of the type of situation that we are talking about here. So in this case we can say time 1, time 2 to just differentiate the first time and the second time, maybe before and the after. So that is what we call the paired sample t-test. That is the only when we can apply it. So let's look at the hypothesis. The hypothesis says that there is no significant change in the mean score of students before and after exposing them to the use of algorithms to solve problems in mathematics class. We assume that there is no significant change. Now, in order to test whether there is or there is no, let's go to our SPSS environment. So here we go to back to data and we copy this uh, data from a zip file like this. So and you see the way the data is arranged here is different from the first and second. So we must take note of this anytime we want to do the analysis. So here we are going to open another new data file. So here, click here and paste, and here we have the two columns. Let me call this one time 1, and call the second one time 2, and here let me label it as pre-test. It's the same thing. Let's label this one as post-test. So the two are scores, we cannot change the value. So in this case we go to analyze as well, compare means and we select paired samples t-test. And here you can see we move the first one to the first and we move the second one to second. So and in this case option is remain the same, continue, because we have 95% percentage of confidence. Yeah, okay, we okay it, and we have this. As you see, it's here one. We have pretest of 41.88 8667, post-test 75, and this. So the number of students still remain 30 because we take them the first time and second time, so the same 30 we are repeating. So here we have the mean, standard deviation after putting the two together. The t-test here is 14.162, while the degree of freedom is 29. So the significant level is 0.001, which is highly significant. Indeed, let's go back to our result here. So we have the result here. So this one is showing that we need to copy the value of t-test to this place, and that one is by double clicking this is going to give you chance to click it and copy it. After this one, we move to this and type it here. So that is this is the value for the t-test. That is 14 points minus 14.60. You can enlarge this a bit for clarity's sake. So this is the presentation of the last aspect of the t-test. So we are just like that, we have come to the end of the t-test analysis in SPSS.